Okay. So let me introduce again. What are the two main compounds that we've been working with? Ionic and covalent. We mostly talked about ionic. We'll talk about covalent a little bit. In my introduction to these, okay. You have your periodic table. I'm going to start asking you valence electrons again. How many valence electrons are in carbon? Count to the left.
4.
4. And nitrogen? 5. And oxygen? 6. And then 7. Okay. Oh, and I got to do hydrogen too. Hydrogen, how many for hydrogen? 1. Okay. So if you did their structures, you just go around and then you pair 3, 4, 5, 6. And sulfur is just like oxygen. And then all of these look like this. And I mentioned the other day that when we get to organic chemistry, that's our periodic table. Pretty much all organic compounds, that's all there is. And truthfully, it's mostly this, with maybe a little bit of these somewhere. And that's what the functional groups are. So that's kind of a review, but let me start with just a hydrocarbon. Oh. No? Okay. Maybe we'll do now. Alright. So look at that. Make a decent sized hydrocarbon. So hydrogen and carbon, if it's just hydrogen and carbon, it's a hydrocarbon. Connect them up like this. There's a hydrocarbon. That's the way it's connected up. Okay. If I said, okay, what if I wanted to put oxygen on here somewhere? All the bonds are satisfied, so I have to take some hydrogens away to get the oxygen to stick on there. But one thing I could do is, what if I took this hydrogen off? Notice this makes 2 bonds, so I've got to figure out a way to get those 2 bonds onto here. I could do this. What if I took that hydrogen and I slid it out like that? And then I brought my oxygen down here. And it's got 2. So 2 pairs and 2 singles. And then I connected like that. That's one way I can squeeze an oxygen on here. You see what I'm saying? That's one of the functional groups. Can you find it on there? We call it an OH, hydroxyl. Do you see it? It's the first one. It's so common, the O and the H bond is so common in organic chemistry. The chemists have just fallen to writing it like this. And the pairs are not drawn on here, so maybe I shouldn't be putting those in there. But do you see that? You see that, right? So what is this thing called? The class. You see it, right? Did somebody say it? Alcohol. That's an alcohol. All right. So oxygen makes 2 bonds. How else can I get? God, it's humid down here. You guys feel that? This piece of paper is like cloth. Okay, here's another way I can get oxygen on here. So instead of having an OH stuck up here, what if I'm going to slide this carbon down. The carbon and the hydrogen with it. So I broke that bond and I slid this out. So now I'm going to take care of these 2 bonds here and here by doing oxygen. The pairs I would draw above and below, but it's not doing the pairs in the sheet I gave you. So you can embed the oxygen in the carbon chain. Do you see that in there? Ethers. You see the ether, the third one down below? So that's another functioning group, ethers. Right. And I'll just go on to a 4-carbon chain because it really doesn't change anything. So, carbon chain, it's sort of like the hydrocarbon chain is a canvas, and you're picking places to put an oxygen wherever you can, just one oxygen. There's another way I can do oxygen, and that's with the double bond. So I'm going to put oxygen here, but I'm going to remove that. I'm going to remove this. And those hydrogens are just going to go away. And I'm going to put I'm going to do it like this. There's those 2 electrons. Here's oxygen up here, and I'm going to use those 2 electrons to make these 2 bonds. And really there's 2 pairs there. It's not drawn exactly like they have it on here. If I angle the hydrogen out a little bit like that, which is it's really just your aesthetic choice to do that. Do you see that one? What is it? So what is this one? You're right. What is this one, you guys? I'm going to start bringing ping pong balls to throw at people. What is this, y'all? What is that? Aldehyde. Okay. So notice this with aldehydes. Let me shorten this just to contrast something. What I did, I'm trying to do all the things I could possibly do with 1 oxygen on a hydrocarbon canvas. I've gotten to 3. Here's a 4th one. And again, I'm going to do the double bond. I'm going to do it like this. So over here I put oxygen double bond on the end of the chain. This one it's kind of in the middle of the chain. Do you see that? That's actually a different function. Do you see it? Yeah, it's there.
Are these both aldehydes? Are these both aldehydes?
That's an aldehyde. This one's different. It is different because it's in the middle of the chain.
Oh, okay. Yeah.
This is ketone. one way you can see this, I mean, you can kind of see it here, that this one's, because these chains can be really long. So if I had a really long chain, there would be two ends. And if I put the oxygen double bond on either end, it would be an aldehyde. But if I put it on the inside somewhere, it's called a ketone. And they're separate like that because they actually have different, very different properties. But another way to think of it, is orders of carbons. And it's number of carbons that carbon is attached to. So how many carbons is this carbon attached to? It's attached to an oxygen, it's attached to a hydrogen, and it's attached here. So how many carbons? One. This is connected to one carbon. So we call that a primary carbon. But we just use this code to go with that. So this is a purposely made sure I have colors today. This is called a primary carbon. How many carbons is this carbon connected to? Two. So we call that secondary. So secondary is this, there's tertiary. How many carbons is this one connected to? So that's a primary carbon. This is a primary carbon. This is a secondary carbon. This is a primary carbon. There is such thing as a tertiary carbon and what we call quaternary. I'll show you in a second. But specifically, one way to look at it is aldehydes have the double bonded oxygens on the end of the chain, and ketones have the double bonded oxygen somewhere in the middle of the chain. But another way to say it is aldehydes involve a primary carbon in their structure. This part is what defines it as an aldehyde. And ketones are connected to a secondary carbon. That's just another way to say it. Sometimes when you're looking at very complicated structures, it's easier to think like this rather than decide where the end of the chain is, because some of these molecules are huge in organic chemistry. So that's both those. Aldehyde involves a primary carbon, and a ketone involves a secondary carbon. So that's the difference between those two. So how many more things can I do with oxygen? Okay, very similar. So that's all the things I can do with a single carbon, or at least all the ones that show up in chemistry. There's another group, functional group. Okay, let me draw it back. This goes well. Where you use two oxygens. So if I do that, carbon still has 4 bonds. I put an oxygen here, and I'm going to do the OH like that. I mean, I could draw it with a bond, but it's so common. The OH is so common. The OH is called a hydroxyl. So if I use two oxygens, I can make this. So all I've done is, instead of having just an H here for an aldehyde, I've squeezed in an oxygen here. What I mean is this. So oxygen making 2 bonds, and I just cap it with a hydrogen here. That's so common that I just do that. That's another one of these. So I've done everything I can do with one oxygen on a hydrocarbon canvas. Now we've got 2, and the key here is they need to be near each other. The 2 oxygens need to be near each other to constitute a single functional group. So you see that one on there? Carboxylic acid. So that's a carboxylic acid. And now, And it can only make 2 bonds, okay. So do you see that one in here? The oxygen, this oxygen double bonded and this oxygen out here. It's just like this, oxygen double bonded, there's an oxygen out here. And then you have more chain over here, and more chain over here. Do you see that one on there? It's an ester. So there is a similarity between this, and I think the way you would differentiate them is you would say, for the carboxylic acid, there's an OH in this single bond position. And for the ester, you have more carbon chain. And this could be just this carbon, or it could be 2 more carbons, or 3 more, and go on for a long chain. But it's sort of like similar to ketones and aldehydes. This is embedded somewhere in the chain, and this one is on the end of the chain. So ester and carboxylic acid. I'll say, when you have a double bond to an oxygen, carbonyl, so in some sense, the carboxylic acid involves a hydroxyl and a carbonyl. Okay. Did I do ether? I did do ether. What's left? Okay, notice everything I've done so far was oxygen. There's 2 structures that involve a nitrogen. Do you see that one? Nitrogen is on the end. If you just look at the nitrogen, you see you've got a carbon chain connected here, and then hydrogen, hydrogen. You should see this. You see that, don't you? What's it called? So that one's called an amine. And then there's one similar called an amide. And this one, I'm going to stick a nitrogen. It kind of doesn't matter what direction these things point. They're showing me oxygen. That needs to go away, so there's 4 bonds. Okay. You see that one? So this involves the carbonyl and the nitrogen nearby. Just the double bonded oxygen to a carbon and the carbon to a nitrogen. That makes it. Yeah, that's it. So what is this? It's an amide. Let me skip the phenol for now. Okay, I've done all of these. So let me try disambiguating a little bit. Okay, here you see nitrogen connected to a carbon, connected to the double bond to oxygen. So you have the nitrogen connected here, where you've got the carbonyl, and then you've got two more bonds. One of them is connected to a carbon, the other one's connected to a hydrogen. This one very similar. You've still got this part in there. But this one's connected to two carbons rather than having a hydrogen down here. And this one, those two other bonds of hydrogen are connected to two hydrogens. So 3 different cases. But here, this one has 2 hydrogens, this one has connected to carbons, and this is either or. You got a carbon and a hydrogen. And I could swap those and it's still the same. Those are all amides. For nitrogen, if you look at the nitrogen, you can do orders on nitrogen as well. How many carbons is this nitrogen attached to? 2. So this is a secondary nitrogen. How many carbons is this one connected to? 3. So that's a tertiary nitrogen in this one.
1.
So that's a primary nitrogen. So this is a secondary amide, this is a tertiary amide, and this is a primary amide. So you can break down the amides in those 3 different cases. You with me? All right. So let me go back to amines. I'm going to turn this back into an amine. And you have the same case if it's an amine. I'm going to take the carbonyl away. So now these are amines. And you have the same situation. You have secondary amines, tertiary amines, and primary. You with me? So you can apply the idea of orders to nitrogen as well. It's just now it becomes how many carbons is the nitrogen attached to. And then you can take the nitrogen containing functional groups and categorize them as primary, secondary, tertiary. You with me? Go back to alcohols. I'm making a hydrocarbon canvas. I'm going to make an alcohol. So I'm going to put the OH here. And this one on. Two carbons in there, I guess. Carbon. All right. Now with OH here. And now what I'm going to tell you is there are primary, secondary, and tertiary oxygens as well. Alcohols. So if we look at this carbon, what's the order of this carbon? How many carbons is it connected to?
1.
And how many carbons is this connected to?
2.
So we would call this a primary alcohol and this is a secondary alcohol. Because the OH is connected to a secondary carbon. Here the OH is connected to a primary carbon. You with me? You can get a tertiary OH, a tertiary alcohol. If this was another carbon, all I have to do is make sure this carbon has 4 bonds. And this carbon has 4 bonds, 4 bonds, 4 bonds, and then it's a legit structure. Now that carbon is a tertiary carbon because it's connected to 3. That's a tertiary alcohol. You follow that? Okay. Let me go back to aldehydes and ketones. And let's make an aldehyde here. And a ketone here. Oxygen. So the C double bond to O is called a carbonyl. Here's a carbonyl. You could say that this carbonyl, what would you say the order is of this carbon? Yes, it's 1. It's primary because it's only connected to 1 carbon. This one is 2 carbons, so it's called secondary. Secondary. Everything's misaligned. So you would think we would call this, I'll say aldehyde, you would think we would call this primary aldehyde and secondary aldehyde. But it's weird, chemists have just decided there would be 2 different meanings. So there's a primary carbonyl and a secondary carbonyl. Primary carbonyls are aldehydes, secondary carbonyls are ketones. And that's really because they have such different properties to each other. This is called something different for this.
What is it called in the second? What's it called a secondary carbon?
This is a secondary carbon. This is a primary carbon. You could, but don't write this down because it's not true. You could say this is a primary aldehyde and this is a secondary aldehyde. But they don't do that. They do that with amines, amides, and alcohols, primary, secondary, and tertiary, depending on what the functional group is attached to. But when it comes to the carbonyl, they have such different properties. This molecule will have such different properties than this one that they just give them 2 separate names. So instead of being primary aldehyde or primary ketone, or secondary aldehyde or secondary ketone, this is an aldehyde and this is a ketone. All right, that's the functional groups. There's kind of one left off here, but so I've used nitrogen, I've used carbon, hydrogen, nitrogen, oxygen. This column here are called the halides. I mean, that whole column, they're just all called halides. I should probably go a little further down because iodine shows up sometimes. This isn't on the list, but it's sort of the last main one that I would mention. You can have, so all of those things only make 1 bond. I'll put Cl there. That's called an alkyl. Alkyl halide, just because it's got an halogen on it. More specifically, this is an alkyl chloride. If this was the Br, it'd be an alkyl bromide. If it was an F, it'd be an alkyl fluoride. All right, let me do this. Those are the functional groups. Double bonds, triple bonds. I mentioned those the other day, didn't I? Double bonds and triple bonds. Can't remember. I did a little bit of covalent compounds, and then I went back to the polyatomics. But let me remind you that you can have a molecule like this, and you can like remove those two hydrogens. And these just go away. And these two electrons can come around here and form a bond. So there's a double bond. And then these two hydrogens can go away. And then these two electrons can come in here and form a triple bond. If there's double or triple bonds, we say that hydrocarbon is unsaturated because it's not saturated with all the bonds it can make. Well, not all the bonds, but all the atoms it can have on it. So that's an unsaturated hydrocarbon. I could take an H2 molecule and react it on here, and this happens very readily. If you bubble this gas through hydrocarbon liquid, it will go boom, those will come out. This will split, and you'll get a hydrogen and another hydrogen. But it's still unsaturated. You put in another H2 onto it, and you'll get that. And now you have a saturated hydrocarbon. So just a little subtle nomenclature. Okay. And one more little detail. It is possible to have a structure like this. This is just carbon and hydrogen. It's not really a functional group. But this carbon, what's the order of that carbon in the middle? How many carbons is it connected to? Huh? It is 4, and the word is quaternary. So it is, the word is quaternary. And we'll write it like that. There is such thing as a quaternary carbon. Notice all carbons have 4 bonds, so everything's fine. But you can't get an oxygen on here now. You can't get a nitrogen connected to it. So that's why there are no functional groups that are like quaternary alcohol and quaternary whatever. Because you can't connect anything else to this. If it's connected to 4 carbons, it's got all its bonds, and you can't do anything more with it. What is that? If you classify it. What is that? Where is the functional group? What is the functional group here? That's what I'm asking you. It's an alcohol. That molecule is classified as an alcohol. Is it primary, secondary? It's a secondary alcohol because the carbon that this is connected to is connected to 2 other carbons.
Aldehyde?
Ketone. Remember that ketones have the secondary carbon and aldehydes have the primary carbon. That's one way to think of it. Another way to think of it is ketones are in the middle of the chain and aldehydes are always on the end of the chain. That. That's an ester. Nitrogen has to have 3 bonds. Okay, what is that? You guys, what is that?
Is it the amide?
Yes, that's an amide. Okay. Okay. Now, picking on the back there, what is that? Can you all see it? What is that? What is that one? Huh? An amide. It's an amine. You see the difference?
Oh, yeah.
An amide has an oxygen in the structure, and it's somewhere in the middle. Carbonyl, and I stick a nitrogen here. That's the amide. If there's no oxygen, and it's a nitrogen can be stuck on the end like that. So what is that? Amine. Let me mess with you. Is it a primary amine, secondary amine, or a tertiary?
Primary.
Primary, because the nitrogen is connected to only one carbon. I just gave away the trick, but. So what is that?
Secondary.
It is an amine again, but it's a secondary amine because nitrogen is connected to 2 carbons and 1 nitrogen. You can have a tertiary amine. I can make these change as long as I want. I can make this a really long chain and this one really long and keep this one short. It would still be a tertiary amine. Okay. It is very common for carbon to make a ring like this. You know what this, you ever seen this before? The 6-membered ring for carbon? Really? Very common. If you took chemistry in high school, this would definitely come up. So carbon with 2 bonds, I can go hydrogen, 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 hydrogen. So I'm gonna get some of the last one on this list, the phenols. Okay, so each carbon has 4 bonds. Something that's even more stable than this, look at these 2 hydrogens I've got here. I'm going to break that bond. These 2 hydrogens will go away. These go away. And the 2 electrons left will come over, make the double bond. And now not here or here, but I'm going to go here and do the same thing. Those hydrogens go away. Double bond. Not here, but here. These 2 hydrogens go away. That. And just to be a little neater, now I can make the hydrogens go straight out. Straight out. Straight out. Straight out. Straight up. Straight out. That's called benzene. And if you stagger the double and single bonds like that, it ends up being extremely stable. That's why it's kind of everywhere in organic chemistry. And if I did this, now it's a phenol. Phenol group. Those are called phenols. It's got an alcohol on that ring. The rings are frequently done with this. You just draw a hexagon. That's another way to draw that. Just a summary form. You don't draw the hydrogens, you just go, okay, oh no, I'm missing the, it's very common to draw it like that. So this is a benzene ring, this is the carbonyl, and that's called a phenol. It can get I will draw hydrogens here. So if I had, I'm going to break the bond with this hydrogen, so there's an electron there. If that were a constituent on a chain, then this would be called a phenol. You with me? That covers all of these. The only one that's not on here, maybe you want to draw it down there on the right, is and that's frequently done. It can be fluorine, bromine, chlorine, chlorine, bromine, rarely iodine, and frequently just as a summary form you'll see just an X written there. And X equals fluorine, chlorine, or bromine usually. Alkyl halide. Here.